So we can, it's working. So we can get out to the observatory, have more fun. So, nothing new this week, because next week we're going to do what?
Test.
Test, midterm test next week.
Will we have to memorize any equations you want to use? Or...
No.
Okay.
You can bring a note card with the equations. Okay, no notes on it, no worked out problems. All we can have is equations. So you can have a note card with equations. Yeah, homework. Yes, and I want your homework for this week too. Please turn that in. Here's a review sheet. Just shows the topics that we've covered. Yes, please turn in homework. Thank you. All right, the way I do the test is the test has typically about 15 what I call short answer questions. Then there's definitions. There's like 10 definitions. 15. Give or take. I actually haven't written it yet, but it'll be around that. All right. There'll be 10 definitions where I just give you a word and you have to tell me what it means. Okay. And then there'll be problems. I usually have about 8 problems, which are similar to all the ones you've been doing in the homeworks. And I actually throw out 1, so you have to do 7 of the 8 problems. I recommend do all 8, and I'll throw out your lowest. So short answer ones are questions kind of like these, like the southeast direction is at what azimuth angle?
Southeast.
Southeast. So remember, azimuth angle is measured from where?
Yeah.
North is 0. Yeah, so southeast is right here. This would be at an azimuth of 135 degrees, correct. Or would a star from with a declination of 52 degrees be circumpolar from Portland, Oregon, which is at a latitude of 46 degrees north? I expect you to draw a picture. What kind of picture would you draw? Bird diagram. Yeah, the good thing is this doesn't have to be the 3-dimensional one. It can just be a 2D one. Remember, I always put north on the left. Okay. Now what do I do?
You do the latitude for the north celestial pole.
Okay, so I go up 46 degrees. North celestial pole, then what?
90 degrees for the celestial pole.
All right, celestial equator, and that's 90 degrees away. Then what?
It's 52 degrees below or above the celestial equator.
Say what?
52 degrees above the celestial equator.
Oh, you want me to put the star?
Yeah.
Okay. So that this angle is 52 degrees.
Yes.
Okay. Now, how do I figure out if it's circumpolar? I mean, that's right, but it doesn't tell me anything about being circumpolar.
Has to be or in 46 degrees of each side.
Of each side of what?
The north celestial.
Oh, now we're talking.
MCP.
So if that's 46 degrees there, what's that angle right there? Yeah, 90 minus 46, which is
44.
What's this angle, by the way? No, it's also 44 degrees, right? Is 52 bigger than 44?
Yes.
So is the star circumpolar?
Yes.
Yes, it is. All right. A blue star, would this have, what's the B minus V for a blue star? I think I heard it. Less than 0. Oh, yeah, anything negative. Okay. A telescope with a long focal length has a smaller or larger field of view.
Long focal length?
Long focal length with a smaller or larger field of view. Well, the longer the focal length, the higher the magnification, right? Because the focal length is projected. So the smaller the field of view, the smaller amount of the sky you can see.
I feel like I remember because it's focusing, and it's farther out, get the focus more.
Whatever works for you. The way I think of it is, remember, what's the formula for magnification? Or the focal length of the eyepiece, right? So if you make that bigger, then you can have a bigger magnification. Bigger magnification means smaller field of view. All right. Right ascension is measured from where? From the vernal equinox. Which way? East or west? East. And it goes from 0 to 24 hours. Get it. Which is longer, a solar day or a sidereal day? Try again. Solar day is how many minutes longer? 4 minutes. That's why it's 4 minutes earlier, because the sidereal day is 4 minutes shorter. Because of the rotation of the Earth, will the star's altitude increase or decrease after it rises, but before it reaches the meridian? Picture this 3D, don't you? Will a star's altitude increase or decrease after it rises, but before it reaches the meridian?
Increase.
Increase, and once it hits meridian, it
Decrease.
decreases. Just think of the sun, right? The sun gets higher in the sky in the morning, lower at night. Yep, same thing for stars. Which one's brighter? A star with an absolute magnitude of 2.4 or negative 1.2? Yeah, smaller number. Given a star with a right ascension of 9 hours, what day will it be best to observe it? Yeah, the star has a right ascension of 9 hours. What day of the year is the best to observe it?
December to March.
Remember, we have the ecliptic measure from the equinox, right? March 22nd, what's the right ascension of the sun? Right? Sun over here on the summer solstice. This is a celestial sphere, I just didn't draw the sphere. Is on June 22nd. What's its right ascension? 6. Back here it's down here it's okay. This is the vernal equinox. This is winter solstice. If the star is at 9 hours, where do we want the sun?
Where do we want? At the opposite side.
Opposite, right? For best observer, we want it opposite. So how many hours is opposite?
21 hours.
21 hours. We want the sun to be at 21 hours. What day of the year, or what approximately is it going to be at 22 hours? Yeah, so it's here on December 22nd. But the winter solstice at 18, right? It's at 24 on March 22nd. So 21 is going to be about the middle of January. Everybody see how to do that? All right. Look like you stuttered. All right. If you change to an eyepiece of greater focal length, what happens to the field of view? Does it increase or decrease?
Greater focal length?
Greater focal length.
Increase. Decrease.
Field magnification goes down.
I got a 50-50 shot and I heard both of them.
Wait,
Field
so
increases.
I'm increasing the focal length of the eyepiece. Does the field of view get bigger or smaller?
Smaller.
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 Field of view,
Final
Oh,
answer.
it's smaller.
yeah, it's smaller, yeah, that's
Oh,
right.
so you just did that, right?
Yeah. But
The
it's
same
different.
question.
Then why are we getting it wrong? If I make this, the objective isn't changing, this time I'm changing the eyepiece.
Yeah.
If I make the eyepiece bigger,
The fraction is smaller.
yeah, which means less magnification, which means bigger field of view.
Increases, right?
We're going to do this tonight at the observatory. Tonight, you're going to measure field of view. The bigger the focal length of the eyepiece, the bigger the field of view. Lower the magnification, the bigger the field of view.
I thought we were going to be looking at binary.
Yes,
Okay.
both.
Okay.
Double duty tonight. So when you go out tonight to the observatory,
Is there something specific we'll be looking at when we do that, like measuring the field of view?
Maybe he has a surprise or
no, I just thought we went over this, but I guess it didn't sink in. How are we measuring the field of view?
Well, it's not like how long it takes for a star to cross the whole thing, but like, I was just wondering.
Yeah, right? So where do you have to aim the telescope?
At a star.
For days.
You can look anywhere, you'll see stars. It's dark, right? Doesn't matter where you point, you'll see stars.
Okay, so we just have to find the star that's at the edge. of
Yeah,
the-
but it is critical where you put the telescope.
Ooh, exactly north.
Or is rotate,
On the meridian.
No, it doesn't matter. if
How
you're
did
Meridian. Meridian works good because it's easiest to look at, but it's not, it doesn't matter.
west to east, right?
Yeah.
Yeah, west.
Which is the maximum circle from east to west?
Ecliptic.
No, try again.
Oh. So it's
The celestial equator.
The celestial equator. You gotta aim at celestial equator. What's the altitude of celestial equator from Commerce, Texas?
57 degrees.
What's the declination of the celestial equator?
0.
0. On the side of the thing, what's it measure? Declination or altitude? Declination, right? Because we pointed towards 90, you're pointing towards north. So you just put that to 0. Okay. Why do you have to do it there? If you put it up close to the north celestial pole, the stars make really tiny circles, and so it'll take a long time to go around. Well, that's not really your field of view. Remember, we calculated how fast it goes across here, right? What are you going to do when you get the time? This was just last week when I told you how to do all this.
No, I did.
Or change it to degrees.
How?
Multiply it by
Divided by 60.
360. Divided by 360.
Yeah. We do have a test next week, right?
Yeah, 15 degrees in an
Yeah,
hour.
50, yeah, I like that.
There are 15 degrees an hour. What's that going to do for you?
It
Well,
means
four-
a fourth of a degree for every.
Yes.
Which is a fourth.
So what are you going to do?
1 argument for
Measure for every second.
Yeah, 1 argument, yeah.
1 argument
For
For every
4
second.
4 seconds.
Yeah,
So you,
that's what it means.
Yeah, 1 argument per second.
What they
So
say.
there's a fourth of an arc minute
Yeah,
every
1 argument
per second, right? So if I get 60 seconds, what's your field of view?
15 arguments.
Yes.
It's 15 arguments.
You just divide by 4, right? So whatever you get for time, you divide by 4, and that gives it to you in
Arc second.
Arc minute.
Arc minute.
Arc minute.
And then you divide by 4 again for the 60.
No, just, that's it, just do
Oh,
that,
okay,
okay?
okay.
So you're gonna time it. And then take that time, which is in seconds, and you divide it by 4. And that gives it to you in arc minutes. The other thing you have to do is you have to make sure the star goes all the way across the center. Don't pick a star that goes across like that, right? Because we want the whole field of view. The other thing I've seen students do is sometimes they don't get their eye close enough. And if you don't, then you're only looking at the center of this. You don't see the actual edges. Make sure you're seeing the actual edges of the field of view. Yeah, I know. With you guys with glasses, it's hard.
I take off my glasses and I can't see the stars.
Are there any field tricks for like, that aren't like written in the books for centering stars and stuff like that? Is there any like,
Field
you can't like lay somewhere, yeah, we're really bad.
I think it's the same thing. Meaning, I think that what you're doing is you're not getting your eye all the way in there. So if you see a circle like this, you say, oh, it's center. But then when I look in and see the whole thing, I'm like, no, it's got to be over here. So make sure you move your eye around and you can see exactly where the edges are. Now, I agree. If you're wearing glasses, you're trying to look through your glasses through it, your eye is further away, so it's hard for you to see all that edge.
Oh, I take my glasses. Like, you know, the
You can refocus it.
It works.
Especially if you're nearsighted or farsighted. Nearsighted, that's better for astronomy. It's kind of weird, but it is. For looking through a telescope, it's better to be nearsighted. Or if you're technical, you can be myopic instead of hyperopic. All right. So those are kinds of questions you'll see in the short answer, right? Definitions would be stuff like this. What is an angstrom?
500.
No,
5,000.
but it's
500. 500.
What was that? Oh, here.
-10 meters.
Yes, it is. It's like an A with a halo on it. It's 1 times 10 to the minus 10th meters.
500.
Now we usually use green lights. Green light has a wavelength of 5,000 angstroms, which is
500.
5,000 times 10 to the minus 10th meters. Or if we go to more normal metric units, this is 500 times 10 to the minus 9th meters, which is equal to 500 nanometers. Or if you want it in scientific notation, is 5 times 10 to the negative 7th meters, which is what you had to use in your formulas, I hope, on this, right? I hope you put that in the right. Okay. What is limiting magnitude?
That's
2.7.
no, he's
I
not.
don't want an equation, I want a definition.
Smallest.
Yeah, but I want it in your head, not in your notes.
The smallest magnitude that it
Faintest star in observer is likely to see
Look at well.
Yeah.
Yeah, the smallest magnitude an observer looking through a telescope can view.
Oh,
Okay, good. What is sidereal time?
Isn't it
As measured from.
by this? Remember this stuff?
By the stars. Time is measured by the stars. You could also put, it's the right ascension of stars on the meridian.
The right ascension of
Stars
stars on Earth.
Correct. What is hour angle?
We know what it is, but we.
The angle measured
But you can't tell me.
I'm putting the answer if you guys guess it.
It's a pain to draw.
How far?
It's tough to draw when you do 3D, isn't it?
How far the star is off the
How
meridian?
angle is some
Like, or
degrees.
anything, I guess?
East or west of the meridian,
So
okay? Which is positive.
the east is.
Let's try again.
West is.
West is positive, west is positive.
East is negative, west is positive.
Looking at.
All right. Then we have problems. These are typical problems. The problems are very much like your homework. So look over your homework. But just for example, yeah.
3-dimensional drawing on the test. How likely?
Well, I was going to put one, but
Which one was?
No, I'm just curious, because it takes me a little longer to draw those, so I'm just wondering.
Oh, the right.
probably not. I do want herb diagrams, but you can do the 2D ones for almost everything, right?
Right.
Like here's a problem: star with declination of 51 degrees. Well, reach what maximum altitude from San Diego, California? Latitude 32 degrees north. Let's do that one real quick. What's your latitude? 32. We're in San Diego. It's 1 degree south of here. I know I lived in San Diego for 2 years, where I got my master's degree. San Diego State University. Great place to go to school. Go to school in the morning, surf in the afternoon, come home, come back and teach labs at night. And San Diego, you know, there's no such thing as weather. I don't know why you'd be a weatherman in San Diego. It's 70 degrees and sunny all year long. It never changes. For maybe 1 week in the summer, it gets hot because the wind turns around and blows off the desert and it's really hot, and then the whole city goes to the beach. But the rest of the time, it's all the same. Never change. You rarely get clouds, you rarely get anything. If you like that, it's perfect. If you like seasons, you get bored. You're like, man, nothing ever changes. What am I going to do? I'm going to go 90 degrees to the west of the equator, then what? We're figuring out the altitude of a star with a declination of 51 degrees.
51 degrees declination. Plus, yeah. 51 plus.
Don't do 51 first. What do you do first?
Oh, measure the angle from special.
Yeah, because it's always measured from here, right? It's not measured from over here, so you got to have this first. So that's 180 minus 90 minus 32, right? Whatever's left over is going to be. Look, it's only 1 degree difference in latitude than we are, right?
Yeah.
So we're 57, it's at 58 because we're at 33, right? This is 58. Now where's the star? Yeah, this is positive, so it's another 51 degrees up here, right? So the altitude, 51 plus 58, 109 degrees, and you'll lose points because what? Yeah, this can't be bigger than 90 degrees. So if it's bigger than that, it means we were supposed to measure it this way. So the easiest way is to do it this way every time, but if this number is bigger than 90, you subtract it from 180. In this case, it gives us 71 degrees.
Okay, so essentially, if you do get the big number, you then subtract that from 80.
Yeah, if this number ends up bigger than 90, subtract it from 80.
Okay.
If not, then you're done. Right, because 90 is the zenith straight up, right? So you can't get higher than straight up. So if you go like that, then you should have gone this way, right? You always go to the shortest point. Can you draw a Newtonian in a Cassegrain telescope? Yeah, I talked about it last week. What's the difference between a Newtonian and a Cassegrain? Yeah, the light in the Cassegrain bounces back through a hole in the mirror. Newtonian, it bounces out the side of it. Yeah, that's the biggest difference.
Refraction and reflection.
Those are reflecting only. Both those are.
Oh, okay.
All right, and everybody just turned stuff in last week on this, right? A star has a paramagnitude 3.7, Another one has an apparent magnitude of 11.1. How much times brighter is each star, one star than the other?
So you take the difference. and
Subtract it and you take 2.512 raised to that power, right? Where did 2.512 come from?
That's 5 times 2 is 100
The
times.
fifth
Yeah.
root.
Yeah, so it's the fifth root of 100. You take the fifth root of 100. Good. And a wavelength of 5,000 angstroms. A 3-meter telescope can see to what angular resolution? That should have been the stuff you just turned in. You use the sine theta is equal to the 1.22 and over the biggest deal there is making sure that both of them are in the same units, right? Wavelength and diameter are both in meters. And then visual limiting magnitude. 2.7 plus 5 log D, where D is in millimeters. Yeah, it's a little weird. The other one's in meters, and then you make this one in millimeters. Okay, a telescope with a focal ratio of f12 has a 700 millimeter diameter mirror and a 23 millimeter eyepiece. What is the magnification? But you weren't given the focal length of the objective. You're given it's an f12. You're given that the diameter. What did I say? 700 millimeters. And your eyepiece focal length is 23. What do I do? Good, yeah. If you have a focal ratio, this tells us how far the focal length is away from the diameter, from the mirror, in terms of diameters. So you take 12 times 700, which is a big number. 8,400. And then you use this equation. So you can take 8,400 divided by 23. And you get 365. What units? Yeah, you just put times. 365 times bigger. There's no actual units. Units cancel. Right? Millimeters over millimeters.
So wait, do you have this ratio for both your objective and your eyepiece?
No. It's only for the objective.
Okay. What does this tell us about the telescope?
This tells us that when you have whether your mirror, if your mirror is really flat like this, then you'll have a really long focal length. If your mirror is really curved like this, it'll have a really short focal length. Right? Okay, so yeah, they're the same diameter. They're supposed to be the same. So a short focal length means the light focus is really close. So the light on this one would focus right here. Right?
Oh, it's a small telescope.
But this one, it would focus way out here. Okay, so this one has a really long focal length. This one has a really short focal length. So it determines how big your telescope is, how long it is, which also changes your magnification, right? Because it changes the focal length of the objective, which changes your field of view.
Yeah, everybody describes this now.
Yeah. So the smaller this number,
The smallest number is better.
the shorter your telescope, the bigger the field of view,
The better.
the brighter the stars, the faster the pictures you can take. So usually you want shorter. Now, if you're looking at something like details like planets and stuff, longer focal length is actually really good, but most of the time, shorter is better. All right. What size telescope is necessary to resolve a binary star which has a separation of 1.8 arc seconds at 5,000 angstroms? Yeah, you use this equation again, right? Is it 1.22? The difference is we're solving for D, right? Now you got to be careful because I gave this to you in, I gave it to you in arc seconds. Arc seconds, but what's this have to be in? Degrees, if your calculator is set to degrees, which it should be. Okay. So yeah, make sure you convert that first, and then you're going to solve it for D. And then here for lambda, we're going to put in 5 times 10 to the minus 7th. That's usually what we use for the wavelength, because it's the center of the visual spectrum.
Yeah, my problem with that homework problem, the same one as I didn't do sine theta. I just did, okay, he gave us the degree. I thought he already, took the inverse of it, but no. No.
I didn't do that.
Can we go to the last question for the homework board?
Oh, which telescope do you use?
Yeah.
Okay. For a bright planet like Jupiter or Saturn, they're actually very small, but very bright. So what you really want is something with a really long focal length, really high magnification, but it doesn't have to be very big because you don't need much light. So most people like a refractor. 5-inch refractor gives you really good views of the planet.
Okay, correct.
Did you get lucky?
Yeah, I think so.
Now, open cluster, 3/4 of a degree across means you need a really big field of view. So a big field of view means you need a smaller telescope. So in that one, I would have put the 5-inch refractor or the 10-inch, probably the 5-inch refractor.
I've never looked through a 5-inch refractor. Looks as good as that 10-inch out there.
It does when you're looking at something like the Pleiades, which are really big, they're over a degree across.
I was thinking about measuring all the angle resolution for all of the telescope and then comparing.
Angle resolution only matters when you're doing like really close binary stars, which I think is one of them. So a very close binary star, you actually want the 27-inch because the bigger the telescope, the tinier it is.
We can even use the 10-inch one. So I included both 10-inch because I calculated the angle resolution was so much.
Yeah, well, I guess, once you're above about this big, then it's above 1 arc second anyway, the scene, which we'll get to, the atmosphere messes you up anyway. But the reality is the bigger the telescope, the better the resolution. Okay. For a faint galaxy that's really small, you want the bigger telescope. You want to catch as much light as you can. So you pick the 27-inch. The biggest telescope you can for the fainter the object. For bright objects, not necessarily.
So I looked at, right?
The what?
The binary star.
The very close binary, you want the best resolution, which is what you're going to try to do tonight. Remember I gave you a list of binaries? Yeah. You're going to see if you can separate. Well, the bigger the telescope can separate smaller and smaller details.
So the 27.
27 would be best, yeah.
And we
Well, that's really bright.
Well, we don't know. I didn't say, I said a very close binary. It could have been really faint.
So wait.
Or bright. I didn't tell you, did I?
we can still use the refractor for the binary stars, but 27 is.
Well, with the refractor, you won't be able to separate them because the smaller the telescope, they'll just look like one star. You can't split them apart. So for a binary, something really close together, you want as big a telescope you
I don't
can.
know how close, like, what do you mean close? So what is the arc section or arc minutes?
1.2. I don't know, did we do poorly on that? Is that what we're saying?
Yeah,
Yes.
one was correct. Yep.
Somebody did better.
I
got one
all
or
the
two right.
I included all the telescopes.
Josh did one.
Yeah. Now we'll get number 2.
Any questions about the test? So those were kind of the questions you're going to get on the test. I just don't want you to be surprised when you show up for the test. You shouldn't be. You know my test, so I don't give you anything that we haven't already covered.
It is next week.
You can't choose your book, no. But you can have a note card with equations on it, just equations.
And you can walk that whenever we turn the test.
No, but I'm gonna look at it. I'm gonna wander around and look at it, but no, I don't have to keep it.
I don't really like the book we have.
You like the book?
No, I don't like the book. It's so, yeah, it's confusing.
It's confusing.
It's better
It
to-
covers more stuff than I cover. Yeah, I kind of like, oh, it has like 50 pages, and I just pick up the most important if you read this. Yeah.
Still, yeah, I don't know, it's, yeah, I like to maybe like to watch YouTube or Google something, instead of watching the book is that, I don't know.
It's okay as long as you're YouTubing good stuff.
It just makes like easy topic really hard.
Yeah, some books are good, but
Yeah.
this one I don't know.
Mostly what's
I don't
that,
really
really
I'm very good with
I gotta admit on the whole, the chapter on the celestial sphere, he gave you way more complicated
Yeah,
stuff
yeah.
than you really needed. So he made it harder than it needed to be.
Even the pictures are like,
But yeah,
How long are you gonna want us to take on that early? Are you,
3 years.
is there time?
is there a time limit? Yes, time limit, it's roughly an hour.
Okay.
Meaning if you go a little bit over, that's okay.
Are we going
Is
to
this the
observe
only-
it after the exam or?
Yeah, so next week, you're gonna come, you're gonna take the test, and then you're done. It's gonna be a really easy week, okay? We're not going out to the observatory. 2 reasons, well, I don't know if it's gonna be clear, and the moon's gonna be really close to full. So it wouldn't be a good night to go out anyway, so you're gonna take the test, and you'll be done in an hour and a half, and it'll be an easy night, okay? Then we'll get back to regular the next week.
So we're having a final, but are we having another meeting?
No, just one midterm.
Okay, just one.
One midterm, final, and your notebook, and then the homeworks, right? That makes up your grade.
Okay.
So, and we may do another in-class activity if we get clouded out some more. We'll have to see how it goes. We did one, you know, with the celestial spheres. But I have like one other, so usually if we don't get clouded, if we get clouded, I have 1 year when it just seemed to be cloudy every Monday, and the rest of the week would be fine. And that was bad, and we didn't get out very much, but this year we've already done pretty good, so I'm not complaining. This year we're right on track. So as long as it keeps up. All right, let's go to the observatory. So before you go out there, just to make sure you're clear on what you're doing, before you plug it in and turn on the hand thing, don't even put in the plug-in or the hand palette. You're going to do this first because we don't want it turned on. Because as soon as you turn it on, it starts to track and it follows the stars. We don't want it to do that. So all you're going to do is use the clamps and move it to somewhere along the celestial equator. And then start looking through it, watching for a star, watch the star go across, and have somebody time it. You have to do that for 3 different eyepieces. Okay, so you swap out eyepieces. And then when you're done with all those, and you figured out what the field of view of each of them is, then you're going to align the telescope, plug it in, use the hand pad, get it all set up, and go find those binary stars. And see if you can see. It'll look like one star, but if you look really close, hopefully you'll be able to tell that there's 2 stars. Some are easier than others, obviously. Depends on why it's different. Same thing as before, make sure I get a look through whenever you find it. Well, I don't want to glance, just make sure you're doing it right, but yeah. I have students that look at something and say, oh, here it is, and I look at it, and it's like, no, you're not looking at the right thing, so.
Just want to make sure.
I want to make sure you're looking at the right thing. All right, we'll see you out there.
Just for my future reference, Russ observing.
Yeah, I heard it went pretty good.
I clicked it. The choice number that I used was the Andrew one.
Oh, Sophia.
Oh, it's the camera.
But she just said that. Huh?
The
Oh,
camera.
the camera that you used?
Yeah,
Is that what it's called?
yeah, it's an and/or CCD camera.
Okay, so I put the right thing on the end of the night thing.
Yeah,
Okay.
yeah.
Okay, I was just checking because,
And there was one part where it says program.
oh, I didn't know what that meant.
That meant, what are you studying? So you should have put down white dwarfs.